All right, let's go through the questions. The first question is asking you to evaluate the limits and justify. Okay. Question 1, part 1 is find the limit is x tends to infinity of e power minus 1 over x squared. By the way, how did you find the quiz? Easy, difficult? You guys hear me right? Hello? Can you hear me? All right, thanks, Stephen. Okay, how did the quiz go? Was it easy, difficult, middle, like reasonably okay? Not well. Okay, that's all right. We'll go through. Okay, we'll go through the solutions. The solution is already released, but let's go through this. Okay, how do you find the limit of this function? What sort of approach? We did discuss this in one of the examples. P series, is this a series? This is not a series. This is a function. Remember, we did discuss about limit of composite functions. Okay, so you're going to use that method. Okay. Let's say limit x goes to infinity of minus 1 over x squared. What is this limit? What's this limit? Zero. Yep. So then the next part is since exponential function is continuous, we have maybe possibly okay, we have limit x goes to infinity of e to power minus 1 over x squared is equal to limit x tends to infinity of e to the power zero, which is 1. Okay, that's the first part. The second part is limit as x tends to 2 of x minus 2 divided by cos of pi x plus 1 minus x. How would you approach this? How would you approach this? L'Hopital's rule. Why? Yeah, this is at x equals 2, we got 0 over 0 case. So that means using L'Hopital's rule, we have limit as x tends to 2 of x minus 2 plus pi x plus 1 minus x is equal to limit as x tends to 2 of you derive both numerator and denominator x minus 2 d by dx of cos pi x plus 1 minus x, which is equal to, what's the derivative of numerator? 1. Thanks, Shepherd. Derivative of denominator. What's the derivative of denominator? Okay, what's the derivative of cos x? Yeah, it's minus pi sine pi x minus 1. So that's limit as x tends to 2 of that one. At x equals 2 sine 2 pi. What is sine 2 pi? 0 minus 1, which is minus 1. Okay, that's the second part. The next part is for the third part. You are asked to show that limit of as x tends to 0 of fx, where you have fx defined as fx is between x and minus x. If x is negative and fx is between minus x power 10, fx plus x power 5 if x is positive. Okay, find limit as x tends to 0 of fx. How do you find this? What's the approach that you're going to use? Anyone? Just give your thoughts. Fx is bounded between two functions. Does this ring a bell to you? Squeeze theorem. Thank you. So you could say that if x is less than 0, you have x is less than 0, you have limit as x tends to 0 of x. What is this? This is 0, which is also the same as limit as x tends to 0 of minus x. Okay. Therefore, limit as x tends to 0 of fx is equal to 0 by the squeeze theorem. Okay. If x is positive, you still got the same thing, similar. X tends to 0 of a minus x to the power 10, which is equal to what? Which is 0, and limit as x tends to 0 of x to the power 5, which is equal to the same. Okay, therefore, limit as x tends to 0 of fx equals 0 by the squeeze theorem. Okay, so in conclusion, from these two parts, limit is x tends to 0 of fx equals 0 for all x, not equals 0, except x equals 0. Okay. Oh, I should not say that. Okay, the next part, sum of n equals 1 e power pi over n. How would you evaluate this? What's the approach you are going to use? Anyone? Geometric, yeah. So what's the first term? First term is when n is 1, so that's e power pi. Plus second term is, third term is, and it goes on. So in a geometric series, you have the series is in the form ar to the power n. What is a here? A is the first term. What's the first term? Yeah. So A is in this case e power pi. What is the common ratio? Yeah, it's 1 over pi. And 1 over pi is less than 1. So what do you conclude? Converges. What converges to what? If it converges, it's A over 1 minus R. So that's e power pi and 1 minus 1 over pi, which is equal to pi pi minus 1 times pi. So that's really e power pi minus 1. In the morning class, if you attended the morning 10 a.m., I made an error here. So please consider that. This is the correct answer. The next part is part 5. Find the limit as x tends to infinity of x minus 2 cos pi x plus 1 minus x. What is this? How would you approach this? Yeah, you should be telling. We did this something like this last week. What's the approach that you're going to use? Yeah, squeeze theorem. So you start with cos pi x. What are the bounds? Cos pi x is between what? Yeah, what's the bound? What's the bound for cos x? Cos x is between which two values? Yeah, so it's the same. Only the frequency changes in this case. Okay, but still it's between -1 and 1. Then you got to add 1 minus x plus 1 minus x to this plus pi x. Then 1 plus 1 minus x. Here on the left hand side, you got cos pi x. Sorry, I missed this part. Plus 1 minus x. 1 plus 1 minus x, which is 2 minus x. Okay, now we need to flip this and we need to divide by 2 x minus 2 and flip this signs, inequalities. So that means x minus 2 divided by 2 minus x, x minus 2 divided by cos pi x, plus 1 minus x is then now equal to x minus 2 divided by minus x. Okay, now you can apply the squeeze theorem. What's the limit as x tends to infinity of x minus 2, 2 minus x? How would you find that? You could do this limit as x tends to infinity of divide both numerator and denominator by, yeah, you could by x. So that's 1, 2 over x, 2 over x minus 1, which is equal to 1 minus 1 to 0. Sorry, equals minus 1. Similarly, you can say limit as x tends to infinity of x minus 2 over minus x, which can be written as limit x tends to infinity divided by, that's a minus 1 plus 2 over x, which is a minus 1. Okay, so therefore limit as x tends to infinity of your fx. Okay, call this fx. Fx is equal to minus 1 by the squeeze theorem. Okay. That's the last part of question 1. Question 2 is, I'm hoping you have the questions with you. Your given fx is equal to 0 e power minus 1 over x squared. That's x equals 0. That's x not equal to 0. Okay, first part is show that f is continuous at any non-zero value of x. How do you show that? If x is not 0, is it continuous? You can argue with this. Minus 1 over x squared is continuous, except x equals 0. Okay. For all points except x equals 0. And since exponential function is continuous everywhere, you have e to the power minus 1 over x squared continuous for all x except 0. Yeah, that's the first part. Second part is calculate the derivative of f for each x not equals 0. What's your answer? What's the rule that you're going to use here? What's the differentiation rule? Chain n quotient? Could you be using chain rule only? Yeah, you can say that that's equal to, because e to the power, derivative of e to the power something is e to the power that something times, then you'd multiply it by the derivative of that something, which is minus 2 over x cubed. So that's minus 2/3 2x over x cubed e to the power minus 1 over x squared. Okay, is that clear? Next part is show that f is continuous at the point x equals 0. How would you do that? We did discuss something like this last week. This is continuity at a point. So what do you need to check? What's the definition of continuity at a point? Okay, you got to check. I think I discussed this last week. You got to check these three conditions, which is from page 102, definition 12. First of all, you got to check whether f of 0 is defined. Is f of 0 defined? Here, a is 0. Okay, you could take a as 0. F of 0 is 0, so x equals 0 is in the domain of fx. Then the second criteria is limit as x tends to a of does it exist of fx as exists. Okay, you can argue it like this. Limit as x tends to infinity of -1 over x is minus infinity, and the limit as y goes to minus infinity of e to the power minus y is 0. Okay, so that exists. The third criteria is check whether limit as x tends to infinity of fx is equal to f of 0. This we know, we already showed that it's equals 0 and f of 0 is 0. So that's also true. Therefore, in conclusion, fx is continuous at x equals 0. Is that clear enough? Any question from that part? No? Okay, the next question is you're given fx is, let me check the question, x cubed plus 4x squared. This is a quadratic function. Find the first derivative and second derivative. What's the first derivative? What's the first derivative in this case? Yeah, it's 3x squared plus 4x minus 20, not 4, 8x minus 20. Okay, a second derivative. What's the second derivative? Yeah, 6x plus 8. Okay, and then second part of the question is find the critical points and classify them. That is, classify whether the critical points are global, local minima or maxima. How would you find the critical points? Yeah, so f dash x equals 0 for x. Okay, when you solve this equation, how would you find the solutions? What type of equation is this? What type of equation is this? Yeah, it's a quadratic. How many solutions do you expect? two solutions. Okay, how would you find the solutions? Okay, remember this formula, ax squared plus bx plus c equals 0 from high school. So the solutions for me, the solutions are applying that formula. I got 2/3 times minus 2 plus or minus square root of 19. It's okay if you use calculator to get the exact numeric values. Okay, how would you find if the critical points are local minimum or maximum? Anyone? It should be easy. I want some responses at least. How do you classify the critical points? Okay, you could use the second derivative test. Okay, that is evaluate the second derivative at each critical point. For this point, I got the second derivative is positive, which indicates it's a local minimum. There is a local minimum at that point, and for the second value, I got f double dash negative, so there is a local maximum at that one. Okay. Third part of the question is how many distinct real-valued roots does f have? Prove your answer by making reference to intermediate value theorem and mean value theorem. How are you going to use these two theorems here? Okay. How would you use these two theorems? Yeah, yeah, the function and derivative both are continuous between these two roots. That's a good start. Then what else can you say? Okay, you could argue with using by something like this. Okay, first thing is both fx and the f dash x continuous everywhere. Then if I let x1 to be the negative root, x2 to be the positive root, and then evaluate f at these two points, is these two x values. For x2, I got fx negative, and for x1, fx is positive. So that means by the intermediate value theorem, there exists at least one root in the interval x1 to x2. But by the mean value theorem, there are no more than one root as f dash is negative in the interval. Okay. Then you could take any other 2 points, let's say minus 10 and 10, and evaluate f at those 2 points. Again, I got like sign changes. That means by the intermediate value theorem, there exists 2 more roots. Okay, then since f dash is positive outside this interval x1 to x2, by the mean value theorem, there are no more roots. So maximum is 3 roots. Okay, any question? Any questions from the quiz? If no questions, I'd like to go through the second section. Oops. Okay. In the second question, second section, it's about exponential distribution. Are you guys familiar with this distribution? Okay. Do you know anything about this distribution? Yes or no? That's okay if you don't know. Okay. In probability theory and statistics, exponential distribution is a continuous distribution that is commonly used to measure the expected time for an event to occur. Okay, for example, it is used in physics to model to measure radioactivity decay. It's also used in engineering to measure the time associated with receiving defective parts on an assembly line. It's also used in finance to measure the likelihood of the next default for a portfolio finance asset. Okay, so the definition of an exponential random variable is if it has parameter lambda, then we write the distribution as x is distributed, like this square sign says x is distributed as exponential with parameter lambda. Here lambda is positive and it's called the red parameter, and x takes values in the interval 0 to infinity. Okay, that's why it's called a continuous distribution. Okay, there are some distributions which takes values on discrete points. Those are called discrete random variables. The probability, one aspect of exponential distribution is the probability density function and the cumulative distribution function. The probability density function is in short called PDF, which is described as lambda e to the power minus lambda x when x is bigger than or equal to 0 and 0 elsewhere. And the cumulative distributive function is described as 1 minus e to the power minus lambda x and 0 elsewhere. Just note the notation. This is PDF is the lowercase of f. PDF is the capital, okay, uppercase of f. Then in general, the relationship between PDF and CDF is described as below, okay? Suppose x is continuous random variable on the entire line this time. So this could be any continuous random variable. Then we compute the probability of x falling within a given interval, let's say AB, as the integral of the PDF from A to B. Okay, this is like computing the area of the curve. And the CDF, which is the cumulative distributive function, is defined as, in this case, is the probability of x falling between the lowest point, which is -infinity, up to a given x value. And then you would integrate the PDF again between those two intervals, okay? Then this is really the relationship between PDF and CDF. If you know the CDF, to get the PDF, to get the PDF, you would derive the CDF, and to get the PDF, you would integrate the PDF. Okay, that's the relationship between those two. All right, now based on that knowledge, can you compute the CDF of an exponential distributed random variable and show that you get this part, 1 minus e bar minus lambda x? How would you do that? Remember the definition of CDF is the integral from the lowest point to a given value x of the PDF. What would be the bound of this integral for the exponential random variable? You guys hear me, right? Okay, thank you. Yeah, Kai, you're right. It's from 0 to infinity because the random variable is defined from 0 onwards. Okay, so this integral would be from the bounds are from 0 to x. And what's the PDF? Okay, you would replace fx by that lambda e to the power minus lambda x and then integrate it. Okay, should be easy. Let me show you how to do that. Okay, I've asked to find the CDF, which is the probability of x less than or equal to x in this case. And then x starts from 0 to a given value x, and then replace in this part as lambda e to the power minus lambda at t, derive this, integrate with respect to t, gives us like this is the general rule for integral of e bar x. What's integral of e bar x? What is this? This is basic calculus. What's integral of e bar x with respect to x? Should be e bar x. What's the integral of ax? E bar ax. That's 1 over a e bar ax. Okay. So applying this rule here, okay, we get integral of e bar minus lambda t is minus 1 over lambda e bar minus lambda t, and then evaluating this at x, t is x and t is 0, we get this part here, which is e power 0 is 1. So we get 1 minus e power minus lambda x, which is what we are required to show. All right. Any questions? In probability theory, we always say where we always give the set on which the probability is defined, and it should be 0 elsewhere. Okay? Because the probability of the entire line should be 1. All right, let's look at the next part. That's question 1. Question 2 is plotting the CDF and PDF for a given lambda. I've done this before. Let me check it. You could use the, there are built-in functions for exponential distribution. Okay, so let me explain this. So at 0, that should be the parameter value of the PDF. This is the PDF. Okay, and the exponential distribution is used in Mathematica to define the exponential distribution with parameter lambda. You can give lambda values, and PDF function computes the PDF of that distribution. And then I've tabulated here the values because lambda varies, and then evaluate that for each lambda and plot the function for x between 0 and 5. Okay, that's how the PDF should look like. And CDF is similar. You, instead of PDF, you would replace CDF. Oops. All right, that's the CDF for each lambda. Okay. See, when the PDF is parameter is the lowest, it's 1 minus that value. So that goes with the, so that's a decreasing function that goes increases, and then the CDF of a random variable will never go above 1. Okay. So that it will be up to 1. Okay, the next part I've explained how to compute mean and variance of a continuous random variable. In particular, mean is the expected value, which is indicated by mu here, is the integral of x times the PDF. And the variance is sigma squared, which is, I will explain you next time how that arrives in general, okay? But you guys should be able to use these two formulas to show that the mean of exponential random variable is 1 over lambda, and variance is 1 over lambda squared. you will need integration by parts here. Okay, could you please try for the next class? Okay, and I'll just continue this next week. Okay, is there any question? Okay, no questions. So then see you next week. Thanks, everyone.